Hello, what is up everyone? Welcome back to a new video, which is a retrofit tutorial video. And for those who don't know what retrofit is, it is just a library to make API calls to access APIs and backends. And in this case, we will be accessing this API that retrieves for us products with their images, price and description and more data. And retrofit is a really easy and straightforward library to do that in a simple way. And Retrofit, yes, makes it really simple to do that. So this is the JSON API that we will be accessing. This is its URL. It's this dummy JSON / products. It's a free one, and this is how it's going to look like. Basically a list of products, and each product with their ID, title and other data like category and description and images. And here are how they look like in our app. So we access the images and the title, price and description. So yes, I say let's get started with our app. Before we get started, you can check my Instagram account, in which I post helpful updates and Android tips and coding in general. You can check it out and follow me if you like what I do there. So back to our app. Let's now go to our gradle.file and see what we need. These are the libraries we need. First one is the retrofit. So this is the main retrofit library or dependency, and this is the JSON converter. So this one just converts this JSON, let's check it out, this JSON into a data class that we can create later, and then OK HTTP and login to get the logs. And then Quail, this one is used for loading images. You could, if you came from XML, you could imagine it as Glide. Glide was a really good library to load images, and this is the same. Quail is a really easy and straightforward one to load images. So just paste these libraries. You can find this app on GitHub, and the URI will be in the description, and then click sign now. Now in our main activity, or actually before in our main activity, let's just create the packages we need. We need two packages for this: the data, which will hold all the data stuff like making API calls and the API and the repository, and the data classes, and then the presentation package, in which will be the presentation one. Basically, we'll have our view model there and screen. For this, I'm just going to create the screen directly here to just make it simple. But yes, if you have a bigger app, you want to create the screen in your presentation package. So let's get started on creating the packages. The first one is data, in which we will have another package called model. So inside, let's just enable this or uncheck that compact to have our packages like this, and then create our package. Our data class, to create it, we don't actually want to create it manually. Instead, what we are going to do is we want to come to our JSON API, and then copy everything. Just copy everything, and then you need a plugin for this. This is the plugin that can create data classes out of this one, so you don't have to create it by your own. So in your model, just create a new, and then Kotlin data class file from JSON. You won't find this if you don't have the plugin, and this is how you can get it. Just go to your settings, then search for plugins. Here are plugins, and yes, just search for JSON to Kotlin class. So JSON to Kotlin class, this one, and then install this package here in marketplace actually, and then click install, and then you'll have it. So in our model package, click create new Kotlin data class file from JSON, and then just paste that JSON we've copied. This is it, and let's give it a name like and click generate. Wait a little bit, and here they are generated. It generated for us two data classes. The first one for the entire thing, which is let's have a look here, which is for this entire thing, which is which holds now this list of products, and these other things like limit, skip and total. I guess they are at the very bottom. Here they are, total, skip, limit, but we don't need those. We're only interested in this one. And then it created for us this one, which is the the product itself, like the single item, which is this one, inside a list. But I'm going to rename it. So this one, I'm just going to call it now products, and then name this one products. I guess that's a better naming. And this is it now for our model package. We just created our packages. Now in our data, we want now to create our API. So our API will be just an interface with a function, and then Retrofit will do everything, will do the implementation for us. So this is how the API will look like. We'll create a new class or file. We'll call it API or products API, whatever you want, and choose interface here. Now in our interface, we'll have one suspend function, because of course we are making API calls. These are IO operations which block the UI. That's why we need to launch them inside the coroutine. So suspend function get products list. So this is our function, and of course it would return products, this one. And then we annotate our function with a get annotation. So Retrofit knows what we want to do with this. So get, and then I'm going to do something, and then I will explain later. So get, and then we'll write products here, like this. So what is this product? Basically we'll have a base URL right here. So we'll write inside, let's create it inside a component object. So component object val or const val base URL. That is going to be our URL, but only the base URL. So the base URL is like until from the start to the ending of the domain name. So let's copy that. So this is the base URL. Let's check another one. For example, on Instagram, the base URL, you could imagine it from the start until this right here, which is the ending of the domain name, and then whatever comes next is just either paths or queries. In our case, it's a path. Why? Because it's directly a slash products, which is a path in our case. So to then add this path to our base URL, we just write it here. So what Retrofit will do is it will use this base URL and then add this path to it. In case we have queries, and what queries are, we can imagine them as values that can change for each user, and it most likely would be the API key. For example, if this API wasn't free and you need to buy or register or create an account, for example, even if it's free, you need to create an account for that, and you have a limit. And for they to know that you reached your usage limit, then you need an API key to know who exactly made the API call. So if this URL had an API key, it would look like this. So we just add this question mark, and here we already have this auto completion here. So this is how the API key would look like. So a question mark, the name of the query, and then is equal then the actual value of the query. In this case, it is an API key. And if we had this, you may have it like an API key like this, or page, for example. If you need to know, for example, this is the first page of products, and then you want to go to the second page, then you need to change the query. To do that, right here, right now, we only have this path, which is an immutable path, so it doesn't change. But in case we want to have a changeable query, then we need to pass that to the function as a parameter. So we just annotate this with a query that comes again from Retrofit, and with the name of the query. So in this case, for example, API key, and then we create it. So it is API key. We create, the parameter string that is of type string, like this. Now we just created the query. Once I call this function, then this path will be added to the base URL, and then the query, this one depending on what I passed. Basically now I'm going to pass the API key, the string, for when I call this one, and then it will eventually look like this if it's page or a query. And then in case we have more than just a query, because that's possible that we may have more than a query, for example page and then API key. So to add that, we just need this to use this end symbol like this, and then the new one. So this is page now, API key, and our API key is something like this, 1 2 3 4 5 6 or something. Now we already created the API key. Now we want to create the page, and that is of type integer. It might be page, it might be anything else, but yes, I'm just trying to explain to you how would this look like if we had queries. So this is it for queries, but in case we have now changeable paths. So for example, we want to load a specific type of products, like only tablets or only laptops, then we can add that, for example, after our products path. So slash, now let's say we want for example tablets like this. So this is now tablet path, and it can change. So as I said, it can be tablets, it can be like phones. So this one can change, and it changes depending on what we want, but products doesn't change. So what is the difference between the two paths? What is the difference between the two paths in the creation? We just always need to add that right here, because that's a path, then it will need to be here. So let's say the type, now of the device that we want, or the products, but we can just add it like this, because now this one is not changeable. But to make it changeable, we just put it inside two brackets like this, and then again we need to pass that through our function like this as a parameter, I mean. So annotate this with a path annotation, and then we say it is type path, so that whatever we passed now will be assigned to this one. And let's say type here, and it is of type string. And yes, now when I call this one, whatever I passed as the type, like tablets, and then that will be assigned to this one, and here we would have tablets or laptops. And then after that, the page and the API key as queries that can change. So to know whether that's a path, then if it's a path, it would just have slash, then the path. If it is a query, then it would look like something like this: page is equal to something, or API key is equal to something. So this is how the URL would look like if we had those, and this is how we can access that, and of course get the products. But in our case, we don't have all of that, it's just directly like this. But I'm just going to keep this function for you in case you want to have a look at it. I'm just going to put it down here and comment it out, because it will give me errors. So I'm now going to remove these things that I didn't need, or I don't need. And yes, this is now for our API function. These are the query annotation and path annotation. I don't need them, that's why I'm just going to remove them. And now after the API, I'm going to create the result class. Basically the result class, I'm going to create it, and then I'm going to explain it. So result, which is going to be a set class. Basically, when we make this API key, not interface, set class, when we make this API key, we may success on loading the data, or we might fail. So an error would occur in case there is no internet connection, or something wrong with the API itself, or some HTTP exception or whatever. So there was an error on loading the data. Now we need to know what happened, and we would know what happened, of course, with a result class. So to get the result, and then the result will be of generic type T, because we want to pass something with this result class. What is the thing? In case we succeed, then we want to pass the data, and in our case the data is going to be the products list. And when we fail, or there was an error, then we want to pass a message, what is the error. So if there is no internet connection, or something is wrong with the API or anything, then of course there would be an error. Then we want to pass a message for some error handling or exception handling or something, then to tell the user there is something wrong, to just tell them. And we can also pass some data with the error in case, for example, when we fail loading the data from the API, then we want to load it. We want to load something that we already cached in the database, for example, then we want to pass that. But yes, this, you get the idea. That's why we need this result class. So let's now create that data and message that we can pass. So var data, that is of course a generic type because it can change. In our case, this is this one, but we can also pass something else for other APIs if we use them. That's why we make it of generic type, to make it reusable. And it is by default null. Why null? Because when we don't pass anything, then why wouldn't it be null? And then the message, so message is going to be of type string, and it is by default null again. So I made a typo here, I have 3 S's. But why would this again be null? In case we succeed on loading the data, then we might just want to pass the data. We don't have a message to pass. So yes, now inside here, I'm going now to create the 2 cases. There are other cases like is loading, in case we are still loading or something, but for the simplicity, I'm only going to create 2 cases. The first one is going to be the success case. So success, and of course it is of generic type T, and the constructor of this class now will take the data T that is nullable, and it will inherit from our result, this one, again T, and then we'll pass the data because we only want to pass the data. Now we'll duplicate this for the other one, which is the error case, and for this one we also want to pass the message, not only the data. So message of type string, and it won't be null because we want to send a message when we fail. So now we want to pass the data and the message. As I said, the data in case we want to pass something else instead of when we get the error from the API. And yes, this is it now for our results class. After that, I'm going to create the interface to get the products. So a new Kotlin class or file. This is going to be products repository. So this should be an R, but this is not a class. It is an interface actually that will have one function, which is a suspend function, because it will access this one from our API that is also a suspend function, and we'll call it get products list. Why am I creating this repository interface? To just depend on abstraction. In case we want to use a different API or something, then we can just change the implementation, but the interface will stay the same for testing, to make testing easier for us. In case we want because when testing, we're not actually going to use the interface, I mean the API, we're just going to create some fake API for that. So this will return a flow, not this flow, but just re-import it, this one from coroutines, and that will return our results class, of course. And now the generic type is going to be a list of products for a product like this. And yes, this is it now for our interface. Now let's create an implementation for that. So inside my data package again, I'm going to create an interface, I mean an implementation, but this will be just a class this time. And we need to pass now an instance of the API, because that's how we can access, of course, the API. So private var API, and this will inherit from our repository product. So products repository, and now let's override the function like this. Now inside here we can get the products by first we need to return, of course, a flow. So let's create space. So what a flow is, for those who don't know, it's just like a sequence of things that can happen. For example, as I said, if we had unloading case in our result, then the first thing we want to emit to the flow is we started loading, and then when we get the data, now here we get the data. When we, of course, to get the data, then we just finished and we now stopped, we emit that we stop loading. And yes, so this is why a flow is really good for these cases. I will actually make a video about flows because I use them all the time in my apps, and I think you should also use them if you don't, because they're so efficient and good for IO operations or like any other thing, but mainly for this case I use them. So we return a flow that is the result of our list of products, and so we create a variable for that. So var products from API, that's what I'm going to call it, products from API, and it is now try because we could get an exception. So to catch the exceptions, the first one could be an IO exception. So IO exception, we're going to catch that. And then the second one that we may get is an HTTP exception. We need to catch that as well. So first of all, let's just handle in case an exception occurs. First of all, we need to print to see what happened, and then we want to emit to the flow that we failed on loading the data. So emit, then of course the result, that the error case that we created inside our result. So result dot error like this, then we just send the message to that. So let's say error loading products, for example. You could have better like exception handling or something to actually tell the user what's wrong, but for the simplicity I'm just going to make like this, and this is message not products. We have an error here, no value passed for data. I mean, this is data, not message, not data. Data needs to be null by default right here because I may not want to pass any data, but as I said, let's go here. In case I want to pass something else here, for example, something from a database, then we can pass that with the data right here. And then when we fail, we actually want to return the flow because there's nothing else to do because we just failed. And the same for the second one. Like this, error loading products when we have an HTTP exception. And now, but when there is no error, I mean, what we are going to do inside our try block, api.get products list. So this will now execute, which is a suspend function. And so in case something goes wrong, then we'll catch the exceptions. We might want to actually catch other exceptions like a general exception. Just actually copy this and paste it right here. This will be just exception, yes, like this, in case actually the exception is none of these types. So this is what would happen if we have an exception. So what we are doing is we want to get the products, and in case something goes wrong, then we just catch the exception here. And after that, after we do get actually the products and there is nothing wrong, so this one is actually not null and we have the products, and just we need to emit that with our flow. So emit outside the function, so actually right here, emit now result dot success now, because we succeed, and then we pass the data that we want, which is products from API, which is this one dot products, because this products from API is actually let's put the cursor on it. So it's of type products, which has all those properties, but we're only interested in this list of products. That's why dot products, because that's what we want. So actually this is it for our data package. So this is how we can get the data from the API, and this is so reusable. So if you want to create a different API, then you can still use this result class, and in case you want a different API or something, then you can just change the implementation and you wouldn't touch this repository, or neither you will touch like your view model where you get these and then show them in the screen. You only want to change this implementation, because literally you can just remove this API from here and then change it with a database, room database for example, and it will literally just work the same, so there wouldn't be any problem. That's why I always say depend on abstraction instead of just directly creating your stuff, because that's not a good practice. Now after that, I'm going to create my view model, but first I need to create a presentation package. So this is now my data package. Now I'm going to create my presentation one to have my view model and screen inside it, but as I said, screen will be just in my main activity. So presentation package, inside here we'll have a view model, of course. So product view model, and that needs to start with a capital letter instead of small one or lowercase one. And now we'll inherit from view model to make this of course a view model. So view model, this one, and with X, but keep in mind I'm not using any dependency injection here. So yeah, if I want to pass something to this constructor, I mean to the constructor of this view model, then we need to create a view model factory for that, which is actually what I'm going to do, because I need to have the repository. I need to pass the repository to call that to get the products, but I'm not using dependency injection. If I would use dependency injection, this video will be a little too complex, and yes, that will handle, like Dagger Health will handle this for me, but that will be too complex. That's why I'm not going to do that. So let's just create now my private var product repository. Of course the interface, not the implementation. As I said, I'm going to depend on the interface, and then the implementation can change in case I want to change it. Now after that, inside my view model, just create space. The first thing we want is a mutable state flow of products, so the products that we want to get from there. So var products, that is going to be a mutable, I mean private var, I did not write var. So mutable state flow, this one, and the type is a list of products, this one, and then the default value is going to be an empty list, so it's empty by default. And then let's create the public one that we will access from our screen. So products, and it is products as state flow, and after that a channel for showing a toast. In case something goes wrong, then we want to tell the UI to show a toast, and we can just send that with a channel. So private var, actually I haven't created any video about flows, state flows and channels yet, and I'm going to create a video because they are so important. They make programming, Android programming, really easy, and yes, they're just so efficient and what they're meant to do. So this is show toast error channel, show error toast channel, just this channel to send to tell the UI or the screen to show a toast. So this is a channel of type boolean, so this will just be a boolean in this case. In other ways we might have had that inside our result. This one, what is it, I don't know, but yes, this one we might have had another case of is loading to know whether we are loading or not, but let's just create a channel for now. You can then do that because it's the same principle. So watch show, I'm just going to copy this name, var show error toast, that is show error toast channel dot receive as flow. So that's now how we can get flow from this. And now inside my init block, I'm going to get the data or the products. So once we fire this view model, then I'm going to get those, and that will happen inside a coroutine because those were suspend functions. So view model scope dot launch. For those who don't know what coroutines are, because I did not, my channel is new and I haven't created a video about coroutines yet, and I use them again all the time. Coroutines basically to make asynchronous tasks, so we don't block the UI because we don't want to make those IO operations that take time inside our in our UI thread that will block the UI, and there will be like lag or glitch or whatever you want to call it. We don't want that. We want our app to be smooth. That's why we do those IO operations or things that just might take so much time inside coroutines. So this is how we can create a view model scoped coroutine. So coroutine inside a view model, you could say. And now we can use our product repository, this one that we've created, to get the products list. And now we got a flow of products. That's why we want to collect the latest one, and this will return the result. Like this. So the result, of course, is whether we have loaded or we failed on loading those. So when results, and we can use Underwood Studio to get the other remaining branches for us. So when there is an error, what we are going to do is we're going to show the toast error. So show toast error dot send now to the UI true. Hey, show the toast error. That's literally what justice means, sending a true. And when we succeed on loading, then we want to change now our products state or list. So result dot data, that's how we can get now the data, of course. And then we just need to make sure that it's not null dot let. This is how we know this is now whatever it executes in here inside this let block. That means this data isn't null. So this will of course get the products list, products like this. So products list is the same, and then our mutable state dot update to the new one, products. I need an O here, and yes, this is it for our view model. So we get the products, and then we update our product state here, and in case there is an error, we just send through a channel to the screen, hey, we have an error, show a toast. A very simple view model. And inside my main activity now, which is the last thing we want to do, but actually I forgot, before our main activity we want to initialize retrofit. So I'm going to create an object for that. In case, of course, we use dependency injection, then Dagger Health will do this for us. But yes, I'm just going not to use dependency injection, so I'm going to call it a retrofit instance. So retrofit instance, and it is an object. What is that? This one. And inside here, this is how we can initialize an instance of retrofit for our API. The first thing we need is to create an HTTP login interceptor, and that is required by retrofit to just log what we are doing, or the API call. So private var interceptor, not equal, but that is an HTTP login interceptor, this one, and it is equal to HTTP login interceptor dot apply. Yes, like this. interceptor and apply. So we need to pass a value for the level, and that is HTTP interceptor, login interceptor level body. This is how we create that. And now we want to create an OK HTTP client. Private var client is of type OK HTTP client, and it is equal to OK HTTP applied client dot builder to build that dot add interceptor, and it is the one that we've created dot build. So now we have the client. Let's just create some space down here, and after that we want to now create our API instance. So var API is of type our API that we've created, and that is equal to retrofit. So this is how now we can create the API. So retrofit dot builder dot add converter factory. So that converts that JSON body to our data class. So that's why we need that JSON converter factory dot create. So this factory converts that dot base URL, which is the one that we've created inside our API. API dot base URL, and then the client, which is client, and build. Oops, not this, but build dot create. Now the API we want, that's what we want to pass here, class.java. So we just created an instance, so I don't seem to need this, an instance of API, and I just initialize retrofit instance. So if I want to use a different API, then I just create a different instance here. I can still use these, but I just create, for example, a second API for another one if I'm using it, but in my case I don't. So yes, this is how we create that. Now after that, I'm going to create my view model factory to pass the API that I've created it, because I don't use dependency injection. In the factory, it just defines how an instance will be created. In this case, how our view model is going to be created, and then we want to tell it that it's going to be the one that we've created here. So private var view model, and by view models, that is my product view models. This is going to be a little too long, little code, but yeah, I don't use any dependency injection. That's why there's no other way to do it. Factory producer, we need that to produce the factory for us. That is an object view model provider dot factory. This provides, of course, the factory, and then override this create function that returns this superclass, but we don't want the superclass. Instead, we want our view model, products view model, and then we want to pass the repository, but in this case we'll pass the implementation. So products repository implementation, this one, and then the API, because that wants the API. So retrofit instance.api, and then we just write as T. And yes, I've just created my view model factory, and I passed the API to it, or the product repository to it, and that I passed the API to. And after that, I'm going to create now the UI, which is the fun part of this. So inside my surface, I'm going to get the states. The product list state is just one state, so var product list that is view model dot products dot collect as state. This one dot value, because I don't want to call value every time I need this. So yes, now we have our list, and we got it from this state. So whenever this state changes, this will also change, and our UI will update. Now we want to show the toast in case there is an error right here. To do that, we need to do it inside a launched effect. So launched effect to do this in a safe way, and the key is going to be viewModel.show error toast channel. So like this, whenever this changes, this will fire, and then we'll see whether we want to show a toast or not. So to get now the value from this, viewModel.show toast channel.collect latest, because we want the latest thing. This will return a boolean show or not. We need a little arrow here, a boolean, and we just check the value of the boolean. So if show, then we want to show it. Then we want to create a toast dot make text. We need context, and we can't create that inside there, but in a composable, in Compose, to create the context, we just need context is equal to local context.current. That's how we can create the context, and then we need to pass that, and then the text is error. I don't know, just say error, and toast dot short the length, and then dot show to show that toast. So now this is it for our toast. Now inside our launched effect, we want to see if we have items or not. So if product list dot is empty, then we don't have items, but else we do. And when we don't have items, we just want to show a progress bar that is going to be inside a box, fill max size, the modifier, and then we want to say content alignment center to put the progress bar, or the circle, actually the circular progress indicator inside, in the center of the box. So circular progress indicator, in case we don't have that, in case the product list is empty. But when it's not empty, this will now execute. Inside here, I will create a lazy column, which is, by the way, the topic of my last video. In case you don't know what a lazy column is, for any reason, you can check my last video and you will know what that is and how you in a deep explanations. So this will take a modifier to, of course, fill the max size, and then we want to center horizontally our elements, horizontal alignment center, to put them horizontally centered, and the content padding, so the padding between, not between, but from the the padding of the content itself that we'll have inside here. Content padding is padding values 16.dp, import dp, and now inside our lazy scope we need items, because we don't actually need index for this. That's why I'm not going to use the other one, which is item for index or something, but this is enough. Now I'm going to create now inside here the product. I'm just going to call it product. How I will create it, and this will take now the product to display its data. So product list I, or it, because this returns index. Just see what that is. This returns the index in which we are, so index. After that, we need to create a little bit of space. So if we check the app, a little bit of space between each product. So using a spacer, height 16.dp. Now I'm going to create this one actually outside here, composable fun product that will take a product like this. And of course we have images here, so we'll see how we can use Quail, which is the library that I have a dependency of to load those images and show them. As I said, Quill is the equivalent to Glide if you used XML before, and we don't have Glide in Jetpack Compose, we have Quill. So in Quill we have an image state that tells us whether we have an image or not. So the state of the image, and inside our state we have the image itself. So image state, that is, remember, assign image painter and the model. Let's just go to a new line for this. The model will be image request dot builder, and then we need context, so local context current dot data. Now the data will be our image URL, and in our case let's go to the API, and it is this thumbnail. What is it? This is the one that will show. We could show different ones, but that's what I want, the image thumbnail. So product dot thumbnail, this one, and the size is going to be size dot original from Quill, of course, and then dot build to build that. So now we have an image state, but actually dot state to get the state out of that. So dot state, now we have an image state that we can check whether we have an image or not yet, and of course get the image out of this state. Now what we need to do, we want to create a column, because we have a column here which holds an image, this text and this other text. So column, that we need a modifier. We'll clip that, so clip round corner shape and set with t.dp to make it kind of beautiful, and then the height of this outside here, actually dot height is going to be 300.dp, and then fill the max width, and then the background is going to be material theme dot color scheme dot primary container. Inside our column we now check the image state. So if image state as assign image painter dot state dot error, so in case there is an error, then we do something and just copy this and paste it in case there isn't an error. So success, not is, actually not as, here we need is. So in case there is an error, then again I'm just going to show, you know, this progress indicator again that will still load in an image, but I won't fill the max size, or just fill the max size, it's the same thing, fill the max size, but oh yeah, this will also take the space of the text, so just fill max width actually, and the height will be 200.dp. I think this is better, and we have our circular indicator. But when we have an image, now we want to create an image instance, an image composable. Now let's create that image, and the painter is going to be image state.painter. Let me just format this. The content description is product.title. Now we need a modifier in our image modifier to give it the size or fill. I guess I need modifier fill width, fill max width, and then the height is going to be 200.dp. So yes, this is it actually for the image. We just need one thing, which is the content scale will be crop. So to crop the image in case it doesn't fit exactly the size we're giving it. Then below this image, in fact below this, all of this that handles the image, we need a spacer to have a little bit of space between the image and the text.dp, so 6.dp. And then we need to create a text to show the title and the price, so text. The text is going to be the product, the title, and then the price. So just like this, you say price is now product dot price. So I guess I'm just also going to add a $sign here. Now this is it for the text, but this we need a modifier to give it some padding. Let me just format this. A modifier to have padding, a horizontal padding, y horizontal padding, so 16.dp, because we just want to have padding from the start and the end here. 16dp. What else? Let me just take this modifier to the top. What else do I need is the font width to make this let's say font size first dot 17.sp, import sp, and font weight will be semi-bold because it is a title. We want to copy these two because we want them for the other one. And down here actually you want to have another spacer. Let's say 8.dp, or actually let's just not have any spacer there. The text for this one is going to be just product or title, not description, and it will be smaller than this, so let's say 30 sp, and it won't have this big text like that. So I think actually this is it for the UI, and this is it for the entire app. There is one last thing, which is the internet permission, because we need internet for this. So internet, user permission, internet. Now let's close this one and just run our app and hope for the best. The app is running and we do have the products and the images, and everything is working fine. Now let's see the other cases I've covered. Let's say I don't have internet connection, so let's turn on airplane mode. It will show an error to us, as you can see, and it will keep loading, but it won't actually load that after I get internet connection because I didn't handle that. But in case now the image URL isn't working, or there is something wrong with the image, so let's go to the image. What is it? This is the title, the URL. In case there is something wrong, will we actually get that progress indicator or not? Sweet. So yes, when there is no image, or when it's still loading, or when it's slow internet connection, then that's how it's going to look like. Now this is the final app. We have a list of products that we used Retrofit to get. So this is a Retrofit video tutorial. Thanks for watching. Like this video if you find it helpful, subscribe and leave a comment if you have any question, and see you in another video. Bye.